Okay, so like I said today, we'll just continue from where we stopped in the last class. We're looking at random first algorithm. So like it's still, like I said, still like the same process itself. So it's still like the same process itself. So what you're gonna do is we already imported the random first before now. So what I'm just going to do is create a variable and say RF model, right? Then random forest classifier. Okay. Then you pass in the parameters. Number of estimators equals to 100. These values are not these values are not fixed actually. So it means that the values can be changed. Uh, okay. Okay. So like I said, the first thing you always do is to just to ensure that you serve like a star sheet. If you want to forest algorithm class, don't forget that before now I said that let me just highlight it. These are hyper parameters, which means that the values are not fixed, they can be changed. Right. Number of estimators, max steps, minimum sample splits, then random states. I think I sort of like explained the way random forest work, right? I think I did that in the last class. Um, let me try to give. I think I gave an example here, right? So let's say that um you find yourself working in the bank, right? And you have direct contact with the customer, which means be like one of these big clients. Yeah, you happen to be like the one managing the person's account, right? And you need advice on, oh, the person is asking, should I invest in this thing, something like that, that kind of thing, right? And you want to be sure so that you do not give, so you don't give like a very, you don't give bad advice. Let me use that word, right? Now, what you can do, I'm trying to explain the way random friends works, just so again, I'm trying to. So I'll just take what I'm trying to say again. Like I said, find yourself working in the bank and you happen to be the person managing the account of like a very big client, get that kind of thing. And the man asks that, okay, since you are my account officer, I'm looking to invest in something, right? Do you think this is a good investment? Do you think I should invest something like that? Yeah, I'm trying to. Now you're not sure, but you want to be sure that I don't know, I'm not sure about something, but it will make any sense that I'm not saying anything as regards to what the man just asked me, right? Now what I can do is what the person can do rather is to like maybe speak to like different managers, right? Should this person invest, yes or no, something like that, right? So let's say you have like five managers. Give me an example. So let's say you have five managers, right? Now five managers who like based on experience, they've seen a lot of things and all that, right? Now you have five different managers, right? That should the person invest in this thing, yes or no, right? Something like that, like yes or no, right? Now that's just the concept. I'm still going to continue. That's just the concept about random first. So you have like different decision trees, right? And each decision tree, uh, what is the word? Each decision tree are going to make predictions. That's just the way it is. Now, like I said, you have five managers. Let me continue what I'm saying. Right? You have five managers. So is that yes or no? So you say, okay, now please, can we vote? Can the managers vote? So those in favor of yes, please signify. Those in favor of no, please signify. Something like that. Right? Now, let's say yes or no. You notice that for yes, you have three. For no, you had two, for example. So it means at the end of the day, you decide to go with the majority vote, right? Okay. You tell your clients, I feel you can invest in this thing, right? So now look at that concept. Now it means that you actually are like you are the one who's going to make the final decision, right? Like telling the client, I feel you should invest in this thing. But before I can tell the client or before I can give an advice to that client, I need to like speak to like different managers, right? Now those managers are like the different decision trees. Remember, at the end of the day, the final decision still lies with you, right? Because you are the client's account officer, right? But you decide to consult five managers, which means that you decide to consult five decision trees. Let me just use that concept to get what I'm trying to say. Now, at the end of the day, you decide to go with the majority vote. It's just two options, either yes or no, right? So after asking them, you say, okay, please just vote. At the end of the day, you notice that three of them voted yes, two voted no, which means that now, at the end of the day, your final prediction is dependent on the majority vote. Do you understand? So what it means is if maybe three persons have voted no, that will mean that you most likely tell the clients no. That's what I'm trying to say. So it means that you based your decision based on the majority votes gotten from what interaction with five managers. Now let's come back to random forest. So what it means is for random forest, they're like different decision trees. Now you know you can have as many decision trees as possible. There's a reason why it's called decision tree. Why? Because like I said, each tree is making decision, right? So it's just like the whole concept of which I feel like one of the reasons why they name it random forest. It's just like the whole concept of when you have a forest, you have like different trees in that forest, right? And each tree will most likely have like fruit and all that, something like that, right? No. So each tree, like I said, is making decision, which is why it's called a decision tree, right? So it means that you can have as many decision trees as possible. So at the end of the day, the final decision still boils down to what? Still boils down to the majority what? The majority vote. Which is why I gave that illustration of the I5 managers, right? Now the question is you can also get more people, you can get more managers as possible, right? So you just reached out to five. So you could increase it from five to seven. So just like saying five, I feel like consulting five managers is not enough. I'm giving an example. Why not increase it from five managers to 10 managers, for example? You know what I'm trying to say? So let's say out of 10 managers, seven voted yes, three voted no. You understand? Now you can see it has increased your, how do I put it now? It has increased your confidence that, okay, you know what? I can confidently tell this man that, once you invest in this thing, you most likely get your return or something, right? So you see that concept I just explained, it's just the way random forest work, where you have different decision trees, right? Each decision tree is making predictions. But at the end of the day, random forest, the final predictions for random forest would be the prediction based on what? Based on the majority. So I don't know if I've been able to like illustrate what I'm trying to say. So that's just the way the random forest are already moved. So just see it as the example I just gave. You have different park managers. I'm trying to make decisions for your clients. I decide to tell them to vote. Five managers, three voted yes, two voted no. At the end of the day, my prediction is based on the majority vote. So if majority had said no, I'll tell my clients, so I don't think you should invest in this thing. But because majority said yes, my final decision will be what? Yes. So I don't know if I've been able to like sort of like explain the way random forest algorithm works, right? So that's like I don't know, that's like one of the examples I saw like just think of or something. Right. So that's just like the way random forest work and all. You can easily still just read through these notes and just try to further understand, right? Okay. So like I said, so this number of estimators would mean the number of trees. So if I say number of estimators equals to 100, what it means is how many decision tree are we going to have? We're going to have 100 decision trees, right? So it's like saying that example I just gave, right? So it means if I say number, so in that scenario I just gave, our number of estimators will be five because we only just consulted five managers. So if we decide to consult 10 managers, it means our number of estimators is going to be 10. I'm just trying to just use this, relate this to that example I gave, right? So number of estimators is 100. What else? Max steps is equals to 10. Now, what you are saying is, remember, there are different decision trees. So that would mean the maximum should be 10. Right? It's like, the way you have, how do I put it now? Still based on that example I gave. We have different decision trees, right? And you see that each tree, right? I don't want to say the length, right? Or let me use the height. It does not have to be above a certain. So it's like saying I need you to create different trees, right? But the tree should not, the maximum height should be 10. I'm just trying to give that illustration, right? So it's like the maximum stuff should be 10, right? Then minimum sample split. And I think I already explained what random state does, right? Just to ensure that um just to ensure that you're actually able to reproduce the result and all that, right? So these are the five parameters, right? After instantiating it, the next thing we are going to do is to what is to fit, right? As usual. And I already explained what this does. What you are doing here is this is the part where the model was. This is the part where the model gets to learn from the data, right? Something like that. So let's just wait. So it's still learning, right? So let me just attach a comment. Model learns from data, right? So you can see it's still okay, it's done learning, right? Now, after that, you can see the model is done learning. What's the next thing we are going to do? The next thing we are going to do is to make predictions, right? So we could say RF prediction, right? Equals to what RF underscore model. Can you see? Dot what? Predicts. So we need to make predictions, right? Okay. You can see this, right? So it has already made predictions, right? So like I said our focus is on the F1 score. So I'm just going to say F1 score, or let me say RF underscore F1 score, right? Equals to F1 score, right? So you now compare the origin. Remember the actual outcome is saved in white text. You're now comparing, instead of writing it, let me just copy this. So you're now comparing it with what the model predicted, right? At the end of the day, I'm going to print what? I'm going to print RF underscore F1 underscore score, right? So, so you can see this, the F1 score is 0.85, right? Okay, so this is the F1 score for random forest. So let's also check out the accuracy score, right? Let's also check out the accuracy score. So all I need to do is change this from F1 score to what? Accuracy, right? So this one soon. Let's get a change it to accuracy, right? And yeah, just copy this, right? And paste it here. Okay. So okay, good. So you can see the accuracy is 0 point. So let me stop here to see if anybody has any question. Please, if this is not clear, please just let me know so that I can go over it again. If this is not clear, please just let me know so that I can go over it again. But if it is, you can drop one in the chat as usual. If it is clear, just drop one in the chat. Like I said, if it is not clear, please just let me know so that I can go over it again too. If it's clear, drop one in the chat. If it's not clear, please drop 0 in the chat. I don't mind going over this again. Okay, so I think it is clear, right? Okay, I need my response just to be sure. I think it's just one person responded. I need my response, please. Okay, so one more response, then I know that we can proceed, right? Okay, so Messi say, can I go by it again? Okay, so let me go by it again, right? So here's this process. You instantiate the algorithm, step one. Step two, the stuff learns from the data, right? Step three, the stuff makes prediction, right? Step four, you compare what's the prediction that is being made by the model, as well as the original results or like the actual outcome. Then remember, when you're comparing, based on, so it's like accuracy. You're using accuracy or you're using F1 score. These are like different ways of evaluating the comparison. You get what I'm trying to. So the first thing we did here was to instantiate the algorithm. And how did we do that? Before now, we already imported random forest classifier. So if I should go up, let me take it up so you can see it. You can see that we already imported, look at it here, from SQL example import. So we've imported, so anything we are using, just know that we already imported it before now, which is why you're able to just call it directly, right? So what we did here was to, what is the word? Use random forest classifier. Now, like I said, these are like hyperparameters, number of estimators, max depth, um, minimum samples, splits, random states, right? These are like different hyperparameters. Now, after this is done, right, the next thing is, this is just you just instantiating. So the question would be, Victor, do I really need to write anything in this? So let me show you something. Question would be, do I really need to write anything in this bracket? It's not a must actually. Let me just show you something. You can let me okay, so let me just put so it does not so you can see it's still gonna work, right? Now, so the thing is, you know, for each of these parameters, they already have their default value, right? So whether you pass in something or not, it is still going to work. Now the reason why you're passing in value, remember, so that's why it's called hyperparameter tuning. So that I look at this value, I used 100, okay, look at the results, it's not so good. You go back, change the value, which is why it's called hyperparameter tuning. It's like you're tuning the value, right? So even though you do not put anything, where's that part? Did I remove it? I think I removed this. So what I'm saying, even though you do not put anything in this case, this is what I'm trying. I'm gonna put it back. So even though you do not put anything here, it is still going to work. Why? It will work with the default values that have been provided by what? The algorithm. You get what I'm trying to say? Okay. So this is just some of the things we that specify. Like I said, these values are not what's the word? They are not fixed. You understand? So you can put any value you want to, right? Okay, you want to use rather. Now you can see in this case, after that, the model, because obviously the whole essence is, if I say machine learning, like I said, the whole essence is the stuff has to learn from data. So when you use fit, when you are using fit, this is the process, or this is the part rather where the model learns from the data. The data is X-train and Y-train. Remember, X-train contains the input data for the training data, while Y-train contains the output data for the training data. So it's like saying this input to give you this result. This input to give you this is why X-train, Y-train. This input gives you this result, something like that. So it learns from the data. It learns the pattern, right? It learns the pattern in this data. After it's done learning, which is why, because once you run, you can see to just stay this information like this. Now, once that is done, the next step is for you to allow it to make predictions. And now the reason why you need it to make predictions because in order for us to test the model, or in order for us to know if the model is doing well, right? Um, what you are going to do is the model has to make predictions. They will compare its prediction with what we expect the prediction to be. Like, I mean, that's why I say the actual output or the actual outcome, right? It's like saying for this particular store, what is the value supposed to be one? For this particular store, the answer is supposed to be zero, something like that, right? Now, so when we are comparing, which is where these different evaluation metrics come into, so there's accuracy, there's precision, there's recall, there's F1 score. Because I already explained this evaluation metrics in the last class. So, but we are using the F1 score because there's data is imbalanced. So the best evaluation metric to use is the F1 score. Like I said, because of what because the data is imbalanced, right? Okay. So now here the model makes prediction. You can see we saved in RF underscore predictions. Now we need to compare the predictions with Y test. Now don't forget that it's predicting the outcome for X test, which means that the output data for X test is Y test. Remember, output, we have X train, Y train. The output data for X train is what? Is Y train. That would mean that the output data for X test is what? Y test, which means that the model needs to make predictions. Once it makes prediction, we'll now compare its prediction to what with Y test. Which is why you can see I wrote Y test and F and RF predictions, which is where the predictions are saved. The predictions got from the model are saved in RF underscore predictions, right? Now, what we decide to evaluate or what we decide to use to evaluate the model is the F1 score. You can see F1 score, is passing the Y test, as well as the predictions gotten from the model. Now, when we ran this, you can see we got 0.85, right? So 0.85, right? We also decided to check accuracy score. We also get 0.90, which is like saying 90%, right? So I think I already explained last part why we are using the F1 score. I said because the data is in balance, so which is why you can see there's much emphasis on F1 score. When your data is in balance, accuracy is really not the best way to evaluate your what's the word? Accuracy is not really not the best way to evaluate the performance of the model. So which is where the F1 score comes into play, which is why we are using the F1 score here. Right? Is there so the question would be, apart from that, is there a way for us to balance the data? There's a technique that we can use, but we've not gotten there, which is why we're just focusing on just evaluation metric itself. So which is why we actually got this And we now also got this. So Messi, I don't know if this is clear now, please. With this, you can just drop on the chat just so that we can continue. Okay, I think okay. So Messi, I'm saying if it's clear, can just drop on the chat, right? I think I've been able to explain it. Okay, so okay, okay, thank you. Now the next thing I want to do is gradient boosting, right? The gradient boosting algorithm. This is like the next one, right? This is like the next algorithm I'm going to use. The gradient boosting algorithm, right? So it's like gradient boosting algorithm. Okay, so it's still like the same concept. Instantiate the class, what else? Model length from data, makes prediction, evaluates. Same process, right? So rather, instead of having to write again, I'm just gonna copy this. And we can sort of like make edit to it. So the next thing would be that Victor, do we necessarily need to like learn all the parameters? So the truth is all these models actually have like a lot of what's the word? They have a lot of parameters, right? And the honest thing about this is you can't learn everything actually. But yeah, there are some parameters that are really important, right? The gradient boosting, for example, it's very, very important. I say gradient boosting. Number of for gradient boosting, you actually have n estimators. You also have some other what's the word? You also have some other like algorithms and some other like hyperparameters that are really important. Maybe I should just write it, right? Gradients. Let me just okay. Uh but we need to import. Sorry about that. We need to like sort of like import this algorithm because we didn't import it before now, right? We need to sort of like import this, right? So we can see which is what I'm saying. From X scaling the example import gradient boosting classifier. Wow. So now we can continue what we are doing. So like I said, each of these are going, they have their documentation. I'll try to drop it after the class by God's grace, just so that you can also like look through it and just see how you can sort of like pay about it, right? So okay. So that's it for this time around. Okay, so I'm sorry, let's change this to GB model, right? What else? Okay, we forgot to add comma here. Okay, what is that thing again? Let me see. Sorry. Oh, see, I didn't put the value here, don't mind me. Okay. So like I said, like these values are not fixed too. I think I talked the values are not fixed. So we are still going to look at how to do hyperparameter tuning, which is where what's the word? Grid search come into play, randomized search come into play. But like I said, we are still going to look at how we can do all of this. This is just us just trying to, like do it without um do it without either like balancing your data technique or using like techniques doing for carrying out hyperparameter tuning, right? That's just like the way it is, right? So this is another algorithm we want to use, right? You can see we are just looking at the algorithms, right? Now the question would be, but Victor, we are yet to see anything. Remember what I said. When you are working on a project, you try to do different algorithms, like use as many algorithms as possible. And at the end of the day, right now, we will go with the algorithm with the highest score. That's which is why you can see we've not saved anything yet. Like what I mean is we've not saved the model. When I mean so save, we maybe save the model so that we can either want to integrate it directly to the application or whatever, right? So we are still experimenting. We've looked at logistic regression algorithm, we've looked at decision tree, we've looked at what did we just look at now? Forgot random forest, then gradient boosting, right? Something like that, right? They also look at XGBoost because you want to be sure that before you go with the final algorithm, you want to be sure that you've tried out different algorithms before like moving forward with like the final algorithm and all that, right? So this is like the gradient boosting algorithm, right? So you all know why we are using classifier because this is a classification problem. So I'll still just stick with number of estimators as 100. Like I said, these values are not fixed, right? So I didn't mention like something called hyperparameter tuning. So that's where grid search, randomized search come into play. I'm still going to look at them, but not today, right? So let's just try to just fully understand like the processes. So you can see it's still like the same process itself, right? It's still the same process. Like we'll feed, we'll what's the word? We feed, we try to we tell the model to make predictions, compare the result and all that, right? Okay, so we're still trying to look at this. So we get to do this. Next is what fit, like I said. This is where the model gets to learn from the data. So just say fit X train, comma, the Y train, right? That's just the way it is. X train, comma, the Y train. That's just the way it is, right? So, okay. So you gotta run this. You can see, I'm just gonna attach a comment and say that the model learns from the data. So it's presently learning from the data actually, right? So it's presently learning from the data, right? It's presently learning from the data. Okay, right. So I think this concept of you know there's something they call it a black box, right? Because I don't know. I think I was having a conversation with someone maybe some years ago, and we just said when you say model is learning, like how do you monitor? How do you monitor the learning process? Something like that. They call it a black box. Like you can't. I don't like it's like someone telling me or someone asking a question that's you said the model learns from data, right? Okay, good, right? Can you like explain how it's learning from the data? Now, the only thing you can explain is the way the algorithm works and all that. You understand? So you see that part, it's like a black box. Because at the end of the day, imagine someone asking questions. Okay, now we created something, right? At the end of the day, the machine is able to learn from the data. But do you really know how it's doing it? It's like I don't know. It's like we've given okay, you know what? It's just good. It's just like saying, for example, you meet people and you tell someone, how are you even learning this topic itself? Like how do you learn this topic is complex? I'll give you an example. How are you learning? Person say, oh bro, I know Sabi how I think they learn this, but I just know that they learn now. So there are just some things that are just like black box. You just know, yeah, the model is learning, but you don't really know what's going on inside. So, like I said, it's something we call black box. So let me just like predictions. So the reason why we are doing this, like I said, the model has to make predictions, right? So the model has to make predictions. Sorry, I'm writing prediction. Predicts. It predicts. Okay. So I'm gonna run this. I'm still gonna go over this again, right? Once the model make predictions, like I said, you need to like compare, right? You need to compare the model's prediction. So just come here and say F1 score, right? Hope it was F1 score is the last in the previous one, just to be sure. Okay, good. So why not just, I mean to just copy this, instead of writing it again, and we can just edit it. Okay, so we're just gonna change this to GB, right? We also change this to GB predictions, right? Then yeah, to GB. Okay. Then we get to run this. So you can see this one now, the score is 0.85, the F1 score. So we can also decide to check the accuracy score, right? So all we need to do is just to change this to accuracy, right? This one to accuracy score. Um, Then okay, yeah, that's that. Okay, yeah, change it to accuracy, right? Okay. Yes. So at the end of the day, this is you can see the accuracy score is 19.8, but like I said, I'll focus on the F1 score because the data is imbalanced. Remember, we've not started talking about how you handle imbalanced data. You understand? So when we get to that when we get to that part, that's when we look at how to handle imbalanced data. That's where you look at oversampling, undersampling, smooth, and some other stuff like that. But now we're just focusing on evaluation metrics. When your data is imbalanced, the best evaluation metric to use is F1 score, something like that, right? Okay, so you can see that we've gotten the F1 score to be 0.85, the accuracy to be 0.90. So what this means goes to 100%, right? Because we multiply by 100, you get 90.86% or 90.87% approximately, right? So let me just try to go over this again. Like I said, the first thing you do is, now, like instantiate this, the class, passing the hyperparameters, number of estimator, learning rates, mark. So, like I said, each algorithm has their own. So they could actually have similar hyperparameters, but sometimes not every hyperparameter is the same. You know, which is why I said you don't necessarily need to, like you don't. You have to like because you see all this algorithm, they have a lot of hyperparameters. You can't. The truth is you can't master everything. So it's just those ones that are really important. Number of estimators, learning rate, mark. These are like the major ones that causes how do I put it now? Then it shows that the model, like maybe the accuracy score is 80%. You tune these values, you can see like a huge difference in what it was and what it is now after tuning and all that. So these are like some of like the major hyper parameters itself, right? So that is just the way it is. So like I said, it's actually the algorithm. This is where the model tends to learn from the data. Yeah, now, because after it's done learning, the next thing is examination. When I'm using that word. So in order for you to see, like it's like saying, in order for me to be sure that you truly understand what was taught in the class, I'll give you an exam. At the end of the day, you write your answer, submit to me, right? So that answer is like the predictions that the model make. So you give me your answer. I will now compare with the original answer for question A is maybe 2, for example. This person wrote 3. He failed, something like that, right? So the model has to make predictions. After the model makes prediction, you can now compare with the original answer. I'm using answer, so you get what I'm trying to say, like the original value or like the actual output for that stuff itself, right? The actual outcome, right? So after compare, you can see we decide to use the F1. So when you are comparing, you are evaluating based on something. It's just like saying, and this is why I try to relate it to like you after writing the exam, you submit. So the question is, after submitting, now different examiners have different grading styles. Some will tell you they use negative mark. Some will tell you what's the word? They have a way of marking, sir. Once they see what they want, they'll give you a full mark, something like that, right? So you can see like there are different like marking scheme. So let's come back to model. So what it means, there are different evaluation metrics. So which evaluation metric do you want to use? We decide to use the F1 score. You can see here, we decide to use the F1 score on the actual outcome with the predictions made from the model. You can see something like this. The moment you run this, you can see you have 0.85%. Sorry, 0.85, don't mind me. Then the accuracy you can see you have 0. So let's say 90.86%, right? I'm using percent here because when you see how accurate is something, it's always over 100%, right? But with F1 score is between 0 and 1. So which is why you can have 0.85. So accuracy, if I say how accurate is something, obviously it means it's 100%. So I need to convert it to 100%, which is why it says 0.9086 times 100%. You most likely know that at the end of the day, your result is 90.87%, right? Let me just stop it to see if anybody has any questions. So I feel like it's because it's still the same process for XGBoost, for LightJVM, and the likes. I'm going to stop it to see if anybody has any question, please, before I continue. So if it is clear, if you have any questions, please let me know so that I can take it. Or if at all it's not clear, please let me know so that I can go by it. Thank you. Let me check the chat. Okay, so can I see all on the same page? Uh, okay, so if it is clear, please drop one in the chat. I don't want to be sure so it does not look like I'm going too fast or it looks like I'm not communicating everybody. So if it's clear, please drop one in the chat. I just need response, please. I need response, please. So here's what we are going to do, right? What I'm going to do is for the other algorithms, I will only instantiate the class, right? But for these steps, I want someone to just tell us how we can do that because we've seen the random forest example, we understand this. We've also seen this gradient boosting example, we also understand. So it's still the same step. So I need more response to this. I'll just call on someone. So the person will just tell us how we can just write our code. So do that, please. I need more response, please. I need more response, please. I want to be sure that we are all on the same page. I need more response, please. Can everyone hear me? Okay. I need more response, please. I need more response in the chat. One, just drop one in the chat with the step. I need more response, please. Only one person has responded. Okay, so I guess you're all on the same page, right? Okay. So you see this XG boost, light DBM and card boost. So some people will tell you that it is a software. Everybody has different explanation for it. Now, you see the I say light GPM. Why do I keep saying light GPM? The random first, decision tree, gradient boosting. These are like traditional ML algorithms, right? This is why we call them traditional because obviously they were created from scratch by someone another, right? Now, but it's the XG boost, card boost, and light GPM. Now think about it. XG boost, card boost. So, and before now we said gradient boost. So what it means is this algorithms are built on top of, or they are built, or they are derived from the gradient boosting algorithm. You see the XG boost, the card boost, the light GPM, right? They are gradient boosting algorithms, which means I see this gradient boosting algorithm we just treated, right? XG boost, light GPM, and card boost, right? They are gradient boosting, which means they work similarly to this gradient. So it's like the work concept around XG boost, light GPM are gotten from gradient boost. So I'm trying to think of a very practical example I can give. So just like saying, what example can I give? Right. Okay, good. So just like saying, right, I don't, can I use rice? So just like saying your what's the word? Rice, right? In raw form, right? It's either you make fried rice or you make jollof rice or you make white rice and stew. But it's still rice. I don't think I'm trying to like it's still rice, just like it's different. What would I call it? Is it different formats? Just like it's different form rather. Like either you want it to be in form of fried rice or you want it to be in form of rice white white rice and stew or you want it to be in format of jollof rice. But it can't take away the fact that it's still rice. So what I'm trying to say is XG boost, light GB and card boost, they are still graded boosting algorithm. So it's like they are derived, like saying they are built on top of the whole gradient boosting concept. So, but that does not mean that they are made by the same person, like different person. Like saying, oh, I love the way this gradient boosting algorithm works. Why not just create our own? Obviously, someone would have just sat down and say, okay, this rice, instead of making jollof, I can make fried rice, right? Someone that there are even other flavor of rice that I don't even know about, right? So we can actually do something. We can prepare rice like that, right? But it can't take away the fact that what is being used to make all of these things is rice. So what I'm trying to say is the card boost, the XG boost, and light GPM, they are still, you can't take away the fact that they are still gradient boosting algorithm. Now, even though the algorithm is standing on its own, the concept is still from the gradient boosting algorithm, right? That's just the way it is, right? So the XG boost, right? It's called like the extreme rename. Like I said, all of these things are taken from the concept of the gradient boosting algorithm. Now, which is why I say some people will tell you that Victor, I'll more or less I'll call this a software because it's like you built it like so it's like you didn't build it. I don't want to say you didn't build it from scratch. Like it's built on top of something, on top of like a concept of something. So like it's like the way you have decision tree and random forest. These are like I don't want to use the word raw, but these are built from scratch. But see the concept about XGBoost, like GPM, they are beautiful. So some people tell you, I rather call this a software. They are calling it an algorithm, a traditional algorithm, because obviously the whole concept about this is taken from another algorithm. So why should I call it an algorithm? I use something to build something. I'll most likely call it a software, right? Like there's just this whole talk about should we call this or should we call this that or something like that, right? But like I said, the concept of XGBoost, light GPU, they're actually gotten from a gradient boosting algorithm, right? So like it's still not like it's still like the same concepts and all that. So yes, what I'm going to do, like I said, right? Um, I'll write the first part, right? And I'll just leave this open so anybody wants to just tell us how we can go about writing the code and all that, right? So what we are going to do is we're going to say from XGBoost. So yes, the thing we need to install this. It is not, it can be found, it's a separate list on its own. So it can be found in the, what's the word? It can be found in the sklearn library. Sklearn, that's scikit-learn library, right? So which means that you need to like sort of like install it on your own. So I can't remember if I installed it actually, but this is how you install it. After click install XGBoost and LightGBoost. Let's just wait for it to install. Okay, so I already have it. So you can see we commented. So I already have it, right? So there's no need. I just wanted to be sure. So it means I already have this, right? So what that means is we can continue, right? So I'll just say from it's still the X, so I'll just say from XGBoost, right? Import XGB classifier. That's like the format for it. Okay. So now let's do something. Like I said, it's not me writing from scratch. It's still the same thing. Just copy. So we don't start, now like waste of time. So just copy and paste it here, right? So we'll just start editing to our own. So this one is going to be XGP. So like I said, it's built. So like what's the word? The gradient boosting algorithm is built from this itself, right? So I'm still going to leave this as it is. Remember, I already said it's a gradient boosting algorithm. So number of estimators, learning rates, max steps, blah, blah, something like that. I'm still going to leave this as it is. Then we run this, right? Now I'm going to create 3 different lines. So I want someone to tell us the next 3 steps, right? Anybody can volunteer. So this way I'm going to stop. So I'll leave it open or I'll call someone. So anybody please. So the next thing is predict. What else? Now compare. Sorry, what we do? Learn, predict, then compare, right? So I want someone to just tell us how we can write the code. Please, anybody. Let me check the chat. Dollar. Yeah. Mention dollar yourself. What about you? So please, anybody. Okay. Nobody wants to say anything, right? Linus, please just speak. Just call on anybody. Let me call my boss to call on anybody. Linus, are you there, please? Okay. Okay. I wouldn't like to just pick someone, but yes. So let me pick someone myself.
No,
Let
I was
me.
speaking. Oh, can you hear me?
Yeah. Okay, please, guys, guys. I could not hear anything. So please, yes, please call anybody.
Where is go now? You shouldn't run away.
Dollar on. Oh yeah, please come outside.
Let me try.
Okay, Grace wants to try.
Okay, Grace. Oh, okay, Grace, please go ahead.
Okay. XGB underscore model dot fit
Okay, so I've done that.
brackets X train
Extreme.
X underscore train
Okay.
Y underscore train.
Y underscore train. Okay. I've done that. What next?
I'm sorry, you run it now. It's not.
Like it's still running. Why?
I
So
think
why
the
is
next
running on this side? twice one on the side will just be, now we'll just continue right now. Code now. So once it's done, we'll just run it. So let's continue.
Uh,
Yes.
okay, so the next one will be to predict.
Okay,
Uh,
so how should I do that?
XGB underscore model dot predict.
Should we save it in a variable or not? I'm just asking. I don't know. Should we save it in a variable or not?
Okay. Okay. So I think we should.
Oh,
Okay,
okay.
so that predict, yes.
Okay. What else?
First, XGB underscore model dot predict.
Okay. Okay. So what should I write in
Okay.
this?
Um, X test, Y test.
Are you sure? So should I I should put white text? I'm asking. I don't know.
Wait, just hold on. Just give me 30 seconds.
Okay.
Mr. Victor, I
Yes,
give
I'm
up.
with you, please. Okay. Okay. So
I'm trying
I've
to
covered
remember
it.
what you said
Yeah.
exactly.
Yes. Just predict X test. Yes, that's all.
X test. Yes.
Okay. So what next?
Um, when we repeat, we predict. Then
Let me just.
F1 score.
Yes.
Yes.
Okay.
Equal
F1
to
school. Okay. So what should I
X
write?
S Y
Y. Okay. Just
Y
Y.
test.
Okay. Y
No,
test.
now Y
Okay.
test,
Okay.
comma XGB underscore predictions.
Okay. Okay. I've added that. Then
Then
we
we
should
have
just.
the then print
Okay.
XGB F1 score.
F1 score. Okay. So that's all right.
You want to do the accuracy?
Okay. So let's be accurate. Let me just copy this and paste it here. So what should I change this to?
We'll change this one to accuracy underscore
Accuracy.
underscore
Okay.
score.
What
Then this,
about?
oh yes, this will change to underscore accuracy. Then the print we
Okay.
also
So this is.
change. The
Okay.
print statement to change.
Oh, okay. Okay. So thank you very much, Chris. Thank you very much for this. Right. Thank
Okay.
you very much. Yeah. So yes, we've been able to train the Exodus model. So that's just the way to, so you can see here in this case we got um 0.859, right? And this case we actually got accuracy of 0.9087. Thank you very much, Chris. Okay, so please, does anyone have any questions concerning this, please? Does anybody have any questions, please? Okay, so I'm guessing we are all on the same page. Okay, let me check the chat. I'm guessing you're all on the same page, right? Okay, so what that would mean that for the next one, we'll call on someone else to also do that, right? Okay, please, any question? No question. So I'm guessing we're all on the same page, right? Okay, right. Okay, so it's still it's still similar stuff itself. It's still, it's still similar concept itself. That's just the way it is, right? That's just the way it is. So, you see, let me just say something about this examples before I continue. So, how do I how do I say this now? There's this book I read. Um, the book is it was written by one guy. The guy is a beast. I'm using that word in data science. It's like a senior. If there's anything like that, data science. He actually wrote a book on how to fine tune algorithms. I can't remember the name of the book actually, but I know I read it like some years ago, right? His name is Abhishek Thakur. He's an Indian. So there was something he said about when working with some algorithms, right? And now he mentioned something that was very important. So he said for XGBoost particularly, there's a trick to it. So he was saying that for max stats, when you are trying to tune it, you use an odd number. That's what he said. Right? He said you use an odd number. Now, the reason why he said that, I'm trying to there's a reason why he actually said that, right? It's just like saying because he has how do I put it now? Uh, if you are mentioning, if you're going to mention the top 50 data scientists in the world, I can tell you that let's say top 60 of them. I can tell you for a fact is there. The guy is extremely good. Abhishek Thakur. So he said that the reason is because according to him, he said all dates actually give a clear middle decision. Now look at the example I give. I'm just trying to use the example I give. Let's just think about it, right? The example I gave in about like me trying to advise my client on what things. So the example I gave where I said a client is looking to invest in something, and he comes and says, "Victor, you're my account officer, right? I want to invest in this thing." I decided to meet five managers. Now look at five is an odd number, right? Now at the end of the day, there's always that guarantee that you most likely get a majority vote. Now, what if the managers are four? Two could vote yes, two could also vote no. Now, if that's the case, I won't have any majority vote. Now, but because it's an odd number, five, if for example now five or seven or nine, there's always going to be like a majority vote. You can see like five, seven, these are odd numbers, right? There's always going to be a majority vote because if I say five managers, definitely if this is what I'm trying to say. What I mean is if it gets to the last point, that's three, maybe like two persons have voted for yes, two persons also voted for no. One person is not going to vote for yes, so the person is going to vote for no, right? So at the end of the day, there's always going to be majority votes. Now, if you look at even numbers like 2, 4, 6, 8, 10, right? There's every possibility that you may not even get a majority vote because what if it's 2-2? So what will now be the final decision, right? That's just the way it is, right? So at the end of the day, you can see with odd number, there's just this thing about majority, right? And because I think before then I don't know, I think I was trying to implement something for a company. I was just reading different books and I just saw that book and wow. And the moment I tried that, God, I never I never regretted that decision. So there are people who they've built different things, so they know what they are saying, right? So which is why sometimes I don't know, like perhaps during the free time, I can just try to read. Not maybe perhaps one might not actually have time to read books, but maybe read I know people write on Medium, right? Just read articles that at least so just try to understand, at least learn more. That's the way me I do it. Sometimes I just take out time, try to read both because obviously the truth is you can't know everything. So you have to learn from people who are way better than you, right? So when they say they've implemented something and they tell you, Victor, this is the way to go, just listen to them. Don't don't because they've done that. What they are trying, they've done it before. So you are saying no now. Go away now. Say no, continue. You did now come and meet, no, this thing did not work. What so like they've implemented like different solutions. When they say something, you know what they are saying, right? So that was one. So every time we are using apart from I'm just this is just me saying anytime I'm trying to do hyperparameter tuning for XGBoost, right? Now I see for Max that you can see yeah I wrote okay, where's the part? Okay, okay, I think did I change it? I see the mistake. I forgot to change the XGB classifier. Let me change it now. So anytime I'm working on a system, right? You see this max depth is always the odd number. So even when I'm doing hyperparameter tuning, see that max depth is always going to be odd number. It's always you can see yeah, I because I copied from the previous algorithm, that is why I didn't change. For X inputs, just always ensure that max depth 3, 5, 7, 9, just use odd numbers, right? So that's what the guy said. And like I said, it's really he also said some other things too about some really advanced but I have to just see it because it's all like related to like what we are looking at here. So that's just like the way it is it is rather. So yes, so now we can move to light GPM. So like still it's still like the same what's the word? It's still like the same concepts and all that, right? So it's still like the same. So wait, it does not mean that if you use other numbers, it's not going to work. Oh. Please don't get me wrong. What I mean is like a trick, like saying when you are working with mark steps, Victor, just try what number? 7. So that does not mean that if you try 6, you will get your result, but it's just saying that you want to get a very, like a very good distance. Always just ensure that your mark steps is odd numbers. That was what I read from the guy's book. So that's just it. So let's move to light GPM. So now you can see we've actually we've installed XGBoost and light GPM, right? So you can just like we can sort of like continue with it, right? Okay, so I'm just gonna say from light GPM import LGB classifier. I don't know. I think I'm gonna share a very funny experience, right? To be honest, that day I don't know what got to me, right? I think it was this competition I tried to join on Kegel, right? And I think the money was $70,000. Now, obviously, if I'd known, I shouldn't have even wasted my time, right? Just focus on that thing. But I felt like I don't know, I just felt so ginger, After reading different books, I was just feeling that yes, yes, my brother. I tried that. I think at the end of the day, was I even in top 60? I don't think so. I was not in top 60. Nah. So like when I say yeah, now let me look at the profile of people I'm competing with. I just knew forget it. There's no point. Let them not waste my time. I saw guys who were CTOs of companies who were like they've been doing data even before I even entered tech. So just imagine just imagine the number of experience even the guy I talked about, Abhishek Thakur, was also in that competition. So just imagine. So I don't know, I just felt that, like you just like guy, I just told myself, guy, you see, sometimes they're just people who me, it's just my own mindset, right? I feel like no matter how someone is good, right? There are always gonna be people that are better than you. So me, I don't even like so for me, anytime I'm actually thinking about things, right? I don't do it because I'm competing. I don't do it because I'm competing with people. I do it because for me, I want to get to a point where I can say that yes, this is like a better version of myself. So not because I want to compete with people. That's the way for me, that's just my own personal experience. So even when I have friends who are way better than me, and sometimes I'll tell them, guy, you're better than me. Like for me, I'm just that kind of guy. So why will I start getting jealous or something? It's just me. For me, like I said, the reason why I'm doing what I'm doing is not because I'm competing with people. But because for me, like I said, I'm on Victor, I need to get to this point in my life where I can say, yes, okay, I really achieved it, but not because I want to compete with anybody. So even when I find myself in a competition, at the end of the day, I do not win. For me, the most important thing for me is reaching out to people who won. So what are the ideas you guys? Oh, this is how you guys did. So I feel like for me, this is just me. So for me, I like learning from people. Okay, this is how okay, so why did you do it like this? Right? Like I said, no, for me, it's just my own mindset. Nobody, I feel like nobody can you can't know everything. So you always need people that are way better than you. So for me, the way me I do my thing is I try to learn from them. I don't see even when I'm competing, it still look like for me, this is just me just sharing my own personality. But even when I'm in a competition, I don't see other people as competitors, right? For me, I think I just feel like, you know what, I'm working on this thing because at least I want to look at this after at the end of the competition. I want to say, okay, fine, you know what, I was able to like do this. I was able to like work on something in this sector. You know, sometimes or like working on something. It was really challenging, but I had to make it so like that's for me just shows that if at all I'm trying to work on any project in whether health or something, right? I've worked on something like this before, so I can easily just, okay, I think I worked on this when I participated in that competition. So these are some of the things I'm able to like take away from that. That's just for me. That's just really my skill. So even when I'm conversing with people who are way better than me, and I'm telling them, you're like, guy, oh, guy, you're better than me. Like, there's no two ways. You're better, you're better. There's no, it's just me. So I'll tell you, you're better than me. There's no two ways about it. So that's just my own kind because I feel like there's no for me. I always see those things as like a learning distance for me. So I learn from people, my friends, and other people. So even if at all, like I'm conversing with someone, you say something that makes sense. That's a good like. So for me, I just feel like you can actually learn from different people. It does not even necessarily have to be people who are better than you, but you can be better than someone. I'm just giving an example, and the person says something, you be like, oh wow, this makes sense. Oh, okay, I think we can go with this, right? So I think this is just my own kind of personal tradition. So that's just the way it is. Yeah, so yeah, for personal improvement. Yeah, yeah, yeah. That's just it. So let's just do this for. I just wanted to just share that. Don't mind me. So let me just so instead of having to write again, I'm just going to like copy this, right? And paste it. Let's like paste it here. Okay. So it's still like the same thing. Like so XGB, there should be M here, pacifier, right? So I'm just gonna run this. And like I said, no, we already like what's the word? We already did I see lights? I forgot to put the H here. So light GPM. So yeah, it's going to be okay. Let's try to like what we did here. So permit me. I'm just trying to instead of having to write it, I'm trying to just copy it so I don't without to start writing or writing again. So okay, okay. So let's move this down. Okay. So LG. Okay. So I think okay. So this is supposed to be LGB model. Okay, L. So I just want to be sure. So yeah, to LGB model, right? Like I think I'm just gonna do this myself because of time. So guys, this is where the model gets to learn from this. Okay, so yeah, let's put. We don't want this thing showing. So I'm just gonna put verbose equals -1. So I can run this again now. So I don't want that stuff showing. Well, also just it's just like a breakdown of whatever is going within internal. We don't need that information. So just do verbose equals -1. What else? What else? What else? Okay. So it's still like the same. So which is why I'm just trying to just I don't want to start writing. Okay, I can just paste this here, right? Okay. So now we just write LGB predictions. Sorry, what's this now? Does predicts. Okay. So you can see like it's still like similar. It's still like the same. It's like the same LGB. Oh, I wrote L. Yeah. So let's change this. Not a must, but I just wanted to just be consistent. That's why I did that. Okay. So yeah, I'm gonna change this to L. So yeah, to L, right? Yeah, to L. I think that's all. So you can see this one now, the F1 score is 0.8, which is higher than what we just saw, right? Let's also do for the accuracy too. So yeah, we just write accuracy. Yeah, to also just write accuracy, right? And let me just copy this. Um, okay, so this is like 0.909. So yes, so this is about the RGB classifier. Let me just stop here to see if anybody has any question before. So this will be like the sorry, I'm scrolling. This will be like the last. So stop here. Gradients. Okay. Okay. Upper parameter tuning. Okay. Okay. Let's. But let me stop here to see if anybody has any questions before we continue. Does anyone have any questions, please, before we continue? Okay, so I guess that we're all on the same page, right? Okay, so I can continue. So what I want to do is now, if you look at this, right? Um, if I should go up, for example, this is 80. I'm just trying to show you the models we've trained, right? This is 86. I go up here, you can see this one is what? 55. Can you see this? 55.8. Let's also still go up. Here we got 85.8. Similar. Let's still go up. Yeah, you can see it's 5.6. I'm using this to see it. Then which one again? The last one. Okay, yeah, we got 3. Then this one, you can see we got 84, right? So now you can see the best is the light GPM, right? Because this light GPM gave us the highest, which is 0.86. So you can see that, right? So this gave us the highest, so which is 0.86. Now, but take into consideration, we've actually not done something. We've not done hyperparameter tuning, which is what we want to look at now, right? How do you tune the parameters? Which is where the quick search, what's the word? The randomized search, what's the word? Comes into play, right? Okay. So, let me try to explain, but don't before I continue. Does anybody have any questions at all? So it does not look like I'm just jumping. So this, does anybody have any questions before we continue? Please. Okay, so I guess I can continue, right? Okay, so now if you look before what I've been at, so before now you actually looked at like different what's the word? Like different algorithms. You also just that you give values to like a different hyperparameters and all that, right? Um Now there's something called hyperparameter tuning because we said light GPM is the best, but in natural sense, right? Light GPM may not actually be the best. Do you agree with me? And the reason why I say that is because now you can see for each of these algorithms, we actually did not test them to their full, and I use the word full capacity. We didn't actually test them to like their best of their ability, right? We just say, okay, let's try 100, let's try, do you understand? So based on that, we can actually say that um light GPM is the best algorithm, right? So what we'll need to do is tune. So let's tune the parameters for each of these algorithms. So if at the end of the day, after tuning the parameters, the highest is still light GPM, then no doubt we know that the final model we are going to deploy would be the light GPM model, right? Something like that, right? Okay. So when you're doing hyperparameter tuning, like I said, the word person hyperparameter tuning. So when you say hyperparameter tuning, what it means is you're finding the best value for each of the for each of the hyperparameters. Now, before now we looked at function. When I say function, functions, they are parameters. I think I saw like things, right? Now they are called hyperparameters because you can change the values and it can increase. When you hype someone, using hype, don't mind. So you can actually increase the score, whatever of the model, right? Now, when you're doing hyperparameter tuning, there are two techniques. You have grid search and you have randomized search. Now, these are like algorithms that are used for. So I think I'm just gonna sort of like give like a very simple. Let me check the chat. I don't mind if I see after class. But like see me, is that what you mean? Kudrat. You can just clarify in chat, please. So they are like different what's the word? They are different. There are two techniques. You have research and you also have randomized search. Now, there's something called overfitting and there's something called underfitting. Right. We have overfitting and have underfitting. Now I'll save this explanation for the next class. Because we are just, we just did different algorithms. So, you know, as we continue, some of those concepts we'll just talk about that. So it does not look like, oh, Victor is just saying too much or something. Right. Now um you have grid search CV and you also have randomized search CV. Now these are like the approach, right? Now I see for grid search CV, what it does is it's oh, okay, okay. Let's see about that. Okay. So now what it does, when it's a grid search, so it tests every possible combination. Now, why for randomized search, it picks a random. Now, let me give you what I'm trying to say. So let's assume that, I'm giving an example. So let's assume that we are trying to tune the XGPU parameter. Now, let's say number of estimators, right? And let me see mark steps, for example. Now, let's say number of estimators. Let's say I want to try 100. I want to try 200. I want to try 300. Let me stop here, right? Now, let's just put that this is a XGBoost algorithm that we're trying to tune, right? So yeah, for this mark state, you have 3, you have 5, you have 7, something like this, right? Now this one want to try, right? Now so it's like saying I have 3 values I want to try. I want to try 100. I want to try 100. I want to try 200. I want to try 300, right? And at the same time, I also want to change the values of max depth to 3, 5, 7, which means I want to try these different values. Now, when you are using research tries every possible combination. Let me explain what I'm trying to say. Let me just put this thing here and write research, right? Now, this is what research does. So if you try 103, look at all. If you try 105, if you try 107, remember 100 is for number of estimators, 7 is for mark steps. Don't forget. If you try 203, if you try 205, if you try 207, can you see that? The last one, 303, sorry, 305, right? 300 and what's the word? 300 and what's exactly? 307. Now you can see that, right? So what it means like saying 3 times. So every possible combination is going to try this is research. So the first try 103, 105, 107, then now 203, 205, 207, try 303, 305. So it's like sort of me doing it manually, right? I'm trying to automate that process. Instead of me going up, check 103, see the results, write it down. Then I'll now go up again, change it to 200, and maybe change this one to 5. Then you go. So it's stressful, right? So which is where this what's the word? This hyperparameter to becomes like research and randomized search. Now for research, like I said, it tries every possible combination. So you can see here it's doing 103, 105, 107. The next one to 203, 205, 207. The next one 303, 305, 307. Right? Now, this is what grid search. So every possible combination is tried. This is what grid search. Grid search. I wrote grid search, right? Now there's not something called randomized search. From the name randomized, you already know that it's speaking at random. I think I wrote the explanation. You can see I said test random combination of parameters. Now, look at something. Just a very simple question. Now, randomized, which means it's not trying everything. It's picking at random. So it can pick 103. It can pick 205. It can pick 307. It can pick 207. Can you see that? Let's say at the end of the day, it picks 305. And let's say it now picks, I'm giving an example. Let's say it now picks 100. Or let's just stop here. Now you can see this. It's just pick and random. So it does not try everything, right? Now I have a question. You say, like I said, it tries every possible combination. From randomized set, random. Picks and random, then try it. Picks and random, try it. Picks and random. So it's not doing everything. It's only selecting at random. Now here's my question. No, so what I mean is when you're selecting at random, remember it's not selecting every single combination. It's just picking around. It can pick 102. It can pick 103. It can pick this. So it's just being a random, right? Now, here's my question. My question is, now if we should do research CV and we should do randomized search CV, right? Now, before I go to that question, right? Please, is my explanation about research CV clear? Please, let me start with that first. Research CV, please, is the explanation clear, please? If it's not clear, please just let me know so that I can explain it again. Research CV, is it clear, please? If it is, you can just write one in the chat. If it's clear, please just write one in the chat, please. This looks like finding this is the way he's done it out of matrix. Okay, Grace said no, it's not clear. Okay, so let me try to explain to you. I'm trying to. Is it permutation? No, permutation is not. It's not combination. Combination and permutation cannot give you this, right? Three combination, three permutation, three. Three. No, no, no. You can't. So the okay, good. Sorry. Now the explanation for this would be that it is doing this multiplied by this. Give an example. Now we have three values here. We also have three values here, right? That would mean that 3 times 3, which means we are going to have 9 combinations. Let me explain again. Number of estimators, we are trying three values, 100, 200, and 300. For max depth, you are trying three values, 3, 5, and 7. Remember, it's going to try every possible combination you can think of. Now, so the question is, how many number of combinations are we going to have? We're going to have 9, because 3 times 3 is going to be 9. Now, once you buy a parameter, you can have more than 4 or 5 parameters. I'm trying to just start with 2, so you get what I'm trying to say, right? Just so you get the explanation. Now, number of estimators is just 3. 100, 200, 300. Can you have more? Yes, you can, right? But just for the sake of explaining, I decided to stick with 3, right? 100, 200, and 300. For max, I decided to stick with 2, 5, as I said 2. Sorry, 3, 5, and 7. Now, what it does, we agree to what it does, it tries out every possible combination. Now, let's start. What is the first value here? First value here is 100, right? So let's start writing 100 with 3. That's the first one. 1. Can you see this? 100 with 5. That's 2. Look at it. Let me try to increase the size of my screen. So yes, you can see 100 with 3 is, you can see this, can you see this? 105. This 5 here, can you see this? 107, you can see this. Is there another value here? No. We are done with 100, right? Let's move to the next value, 200. 203, look at it here. 205, look at it here. 207, look at it here. Is there another value here again? No, we are done with 200, right? The next one, 300. 303, look at it, right? Sorry, did I record this class? Oh, okay. So 303, right? 305, can you see this? Sorry. Let me take this up. Oh, sorry, stay here. Okay, good. 307, look at it here. Can you see this? Now I can see for grid search, every possible combination is being listed out. Right? So it's going to try every possible combination you can take. So what it means is, if for example now we add 9 here, that will mean that, so that will mean that here we'll have 109. Can you see this? Here we'll have 209. Can you see this? Right? Now this is grid search. Grid search tries out everything you can think of. That's grid search, right? Good. Now, but randomized search is select based on random. You can pick 105. It's just like saying, Charlie, sorry, I'm using Charlie. Just like saying, just pick at random, actually. Just like pick at random. Select any values at random. So you can pick 103. It does not mean that this is what it's going to, I'm just explaining. So you can pick 205. You can pick 307, but it's not going to, you can see, I think I look at this. It is not going to try out everything. Remember, it's selecting at random. In this case, you are selecting based on pattern 103, 105, 107 to go back. So you get, but this one is not following, a pattern. It's just selecting at random. You come, let's try this. You come. You get what I'm trying to say? Like, you just select at random. That's what this randomized test do. It does not follow the same process like the way this follows. This is just select at random. I don't know if you get the difference. So, Grace, please, this clear now. Can I write one in the chat if it is clear? With this, you can write one in the chat, or you can just give me your reactions just so I can. Okay, so so now, what about randomized HCV? Does anybody, if this is not clear, please drop 0 in the chat. If this is not clear, please drop 0 in the chat. This is not clear, drop 0 in the chat. Let me check. Okay, so I'm guessing this is clear, right? Now my question, okay, meaning yes, thank you very much. So meaning that if you have more parameters, right, you're going to have more combinations.